Hello, everyone. Welcome, and thank you for coming to my talk. Now, they put me just after Ari's talk. Those of you who were there, I've not got any songs. I've not got videos of the Digital Foundry people talking, but I can maybe top them with dad jokes. So here's the first one. Taking the pain out of engine upgrades or not taking the pan out of engine upgrades? There was a nutrition conference in the South Hall earlier in the week. They probably have that talk. But this is just pain we're dealing with here. So, what's in this talk? We're answering the question, how do we take pain out of engine upgrades? And there are a few answers to this question. We talk about preparing a project for the engine upgrade, so getting it ready to make the process as smooth as you possibly can. And we'll run very quickly through the process of doing an engine upgrade. I'm not actually going to upgrade a project, but we'll just talk through it. Talk about the perforce stream setup, where to merge, avoiding blocking your team because you don't want to be locking your main branch for very long, using automation and commandlets as much as you possibly can, and then basically you have a very long game of whack-a-mole until you're done. And I'll talk also about managing custom engine code changes, and at the end there'll be some troubleshooting. So who am I? I'm Keith Judge. That's me. So I've been in the games industry for almost 25 years now, and this is my first ever conference talk. And I've got another one in a month as well in Brighton in the UK, where I'm also talking about Unreal Engine, but different talk to this one. I've got quite a few ship titles. There's some examples here. Worked on a lot of PC and console games in that time. I've worked with Unreal Engine since 2012, which isn't quite strictly true because back in the year 2000 when I started in the industry, I worked on a very sort of high concept steampunk game, which was an Unreal Tournament 99 mod. Unfortunately, it never got out of pre-production, but maybe there's an alternate universe where it's the biggest gaming franchise around now. And I worked at Epic Games UK in Guildford from 2012 through to 2018. During that time, we shipped 20 releases of UE4 from 4.0 to 4.19. Those wild days where we were shipping a version of Unreal every month. Also worked on Paragon, RIP, and that little indie game no one's ever heard of called Fortnite. And for the last 5 years, I've been at Tanglewood Games, where I'm currently a lead programmer. In Tanglewood, we're a co-dev team. We are built around ex-Epic engineers. There are 4 of us, well, 2 of us are here today. And we call ourselves the Unreal Engine experts, because we try to know everything about the engine. We try and help everyone with getting their projects set up in the first place, gameplay implementation, engine features, adding things to that, platform porting, TRC and XR checks, all that kind of stuff, we can help you, including engine upgrades. And there's some titles we've worked on together there. So why are engine upgrades painful? Well, the main problem is they take a long time, and it's unpredictable how long it will take. So can I have a show of hands? Who here has upgraded engine on either their current project or a previous one? And keep your hand up if you've managed to do it in less than a month. There's a few of you, but not too many. So this is the thing. Because it's such a huge thing, it can take a very, very long time. And also, you've got issues with, third-party code may not be compatible with the new engine version. So sometimes you have to delay your engine upgrade until they're all ready. There are also potentially blocking issues that you can't resolve, and you may have to just abandon the upgrade and stick with the current version of your engine. And can mean work not just for your build team, but for almost all of your team. If there are certain systems that need modifying, you've got to get the experts on your team to do that. So, how do you take the pain out of engine upgrades? Well, the first thing you can try is not doing it. That's not the end of the talk, by the way. So, why not upgrade? It's a valid choice. A lot of titles are still using older versions of Unreal Engine. All the way back to Unreal 3, I think, there are still some titles using that. And they ship regular updates and patches, big player bases. It's still a valid thing to do. Not everyone needs to be on 5.6. And there's no need for your team to learn new features in that case, because you already know the code, you know the features, you know the editor, you're good. You can still cherry pick specific things from Epic. And you have a relatively stable code base. I mean, stable as in it's not vastly changing on you. So as a little demonstration, we've got this classic XKCD comic where it talks about all modern software is a huge stack of things with a tiny little one at the bottom that some random person has been thanklessly maintaining since 2003. But in the case of Unreal Engine, it looks more like this. And the scale varies depending on your game. But to upgrade Engine, you're basically replacing that huge area surrounding in red. And from a software engineering perspective, that's a risk, potentially, because you could break everything. But there are also risks to not upgrading. The longer you leave it, the harder it is to change your mind. If you have a title on an early version of say 4.9 or 4.10, it's going to be ridiculously difficult to upgrade that to 5 now. So moving one engine version up is very feasible, but skipping several is much more difficult. You'd also lose out on new features, optimizations, all the amazing stuff they showed at State of Unreal yesterday morning. You don't get all that if you don't upgrade. And you have to keep up with external dependencies yourself. And what I mean by this is things like platform SDKs, platform SDKs and more requirements for consoles or any new platforms. For example, if you have a game that's on 5.0 and you want to ship it on Switch 2, you've kind of got to do that yourself. You can integrate the code from Epic, but it might be very hard to do so. And cherry picking gets harder over time because the amount of, although you may want a small piece of code, the dependencies that are underneath that and required could be quite extensive. And Epic generally will only support the last maybe 2 or 3 versions of Engine version. I don't actually know what their official policy on this is, but they tend to support the new versions, not the older versions. But ultimately, the choice means if you don't upgrade, the choice means you and your team have to maintain the whole code base yourselves, which is a cost. So let's go back to this question. How do you take the pain out of engine upgrades? Well, the second answer is you pay someone else to do it, which is where Tanglewood comes in again, but this isn't a sales pitch, so let's move on. So the anatomy of an engine version. We've just had 5.6.0 released yesterday, but what does that actually mean? First number, the major version. This increments once every few years. I think Unreal 3 was somewhere in the mid-2000s. I think it depends whether you count Unreal Engine 3 or UDK. Unreal 4 shipped in 2014, and Unreal 5 in 2022. And is likely to cause large breaking changes in your workflows, all the APIs, anything could change when this changed, really. And it also potentially completely breaks the upgrade path. If you were going from Unreal 3 to Unreal 4, you pretty much had to rebuild your whole game. From 4 to 5, certainly 4.26 and 4.27, you could probably reasonably get that into Unreal 5, but it wouldn't necessarily make the best use of Unreal 5. You would have to change a lot of things to use Nanite and Lumen and all the lovely features that Unreal 5 has. And then from 5 to 6, who knows? We'll see. Hopefully it'll be easy. We have the minor version, which is it increments every 6 months, and it's almost a misnaming because there are major features in the minor version all the time. All the things we saw yesterday morning in the State of Unreal show and the other talks throughout this week. Lots of things added, changed, deprecated, removed, you name it. And there's always an upgrade path when this number increments, although it does require quite a lot of work. And the advice really is to try and upgrade this number sequentially. As I said in the last slide, skipping versions increases the amount of pain you've got. And this really is the focus of this talk, is upgrading this minor version. There's also the patch version, which is the .0 at the end. And this really just contains fixes for crashes and regressions that are caused. But APIs will remain stable, so you probably won't have to re-implement anything to get to the latest patch version. And you should always just take the latest patch version for each minor version. I think 5.5 went up to 5.54, if I remember correctly. I can't remember which one it is, but anyway, yeah. So if you were going from 5.4 to 5.5, just take the latest 5.5. Don't step through the individual patch versions. And it can potentially be advantageous to wait for the 0.1 patch because things will be fixed that, whilst Epic samples and Fortnite are tested extensively, they use Engine differently to how your titles will. So as the 0.0 release comes out, where teams will report to Epic that, oh, this broke or this broke, and they'll fix it for the point one. The other alternate option here is you can upgrade to the preview version if you want to test new features ahead of time. So back to this question: how do we take the pain out of engine upgrades? Well, it's complicated, so let's run through it. You need to get your project ready. Set up your project the Epic way. If you search for the Epic way, you'll find Epic's docs on this, and they did a great video at Unreal Fest Prague last year. And you also want to start, if you're starting to upgrade the engine, you need to start with a stable build, which you know for a fact works, that's been QA'd, has everything, all the features work. It's not going to have random crashes and bugs in it. It's something that's been properly tested. You don't want to just pick a random change list and start there, as I've just said. Another thing you probably want to do is resave all your assets. Something I missed from the slide is you also want to fix up your redirectors, because as you're upgrading engine, those redirectors may get, especially older ones, will just go away, and you'll end up with things being broken. And also ensure the project your whole game builds cleanly with non-Unity. So all the individual C++ files can compile on their own, because if you upgrade, it may change the order they're included in the Unity files. Check that all your includes and forward declares are in place. And before you upgrade, fix any deprecation warnings, because if you've got any left over, the code may just go away in the new engine version, and you've just got broken code then. In fact, fix all the warnings, any you can, and this is both for code and assets. You use the map check to show things that are wrong in your levels and things like that. So the other thing you have to get ready is your third-party plugins. You need to make sure that they're ready. So there are alternate physics engines, there are plugins for rendering, there are plugins for all kinds of things. You need to make sure they're ready before you go, because otherwise you're going to be in more pain. So we kind of have 3 difficulty levels for an engine upgrade. We have the easy mode, where your project is built against a completely vanilla engine version. You've made no changes. It could be from the launcher, from GitHub, from Perforce, but your project just builds against that untouched, pristine version from Epic. And this includes Blueprint and C++ projects. Medium mode is where you start with a release engine version, but you add your own custom changes on top. And hard mode is where you ignore the releases and you just start taking code directly from Epic's main branch. This tends to be very large teams that do this, because you need a build team that can maintain this. It's not something that you would expect a small team to be able to manage very easily, because there is a lot of work with it, a lot of testing, a lot of robomerging, all the back-end setup needs to be done for it. So we call this the AAA way. There is actually, the focus of the talk is going to be on the first two, but the advantage of this hard way is that you get preview versions of features as they're coming out. And also, you're spreading the pain out. So instead of having to do the upgrade once every 6 months, you're incrementally pulling each individual change list. And if something breaks, you know where it broke, and you can figure out how to fix it a lot easier, rather than having 6 months of everyone at Epic has added to this thing, and you're just this big block that could be broken anyway. It keeps the cost of integration, like spreading hitches across frames, as Ari was saying. As I said, I'm focusing on the first 2 scenarios for this talk. Might be back with a second talk in a future Unreal Fest. But which is right for you depends entirely on the needs of your project. I can't tell you which is the best way for you. You have to decide for yourself. So for a vanilla engine upgrade, is this just a simple engine swap? Unfortunately, no. And the reason it's not is because your code or your blueprints and your assets may need to change to work with this new engine. You can't just swap it in. And you may be lucky, but it's probably not going to happen. So because this is going to take time, you want to do the work in a separate merge branch to avoid blocking your team. So you have all your content creators and other programmers can just carry on working as normal in main branch while someone else is doing the merge. And you'll likely need to fix up your code, your project, to use all the new APIs and features that are in this new version of the engine. So yeah, and this isn't just a case of fixing things. You also need to change to take advantage of new features in this engine version as well. There may be new workflows for your designers and artists. For example, when the tooling comes in for the nanite foliage stuff, they'll probably have a completely new way to build foliage to what they do now. And automate as much as you can. If you try and do the whole thing by hand in P4V, you're in for a lot of pain. So the thing with automation is, you kind of want to do as much as you can, which is not necessarily everything. And the reason is because it's a cost in itself. You have to build and maintain all this automation. So if you're a large team, it's reasonable to have a set of build engineers and DevOps which can do this for you. But with smaller teams, you probably want to start with some simple scripts that just do the actual integrate and resolving files for you and things like that. And in my notes again, yeah, don't use P4V because it'll take forever and it'll look like it's broken. What I would love to see is future versions of engines, maybe, 5, 7, or even 6, that ships with some kind of standardized automation tool set for the whole upgrade process. So it does all the grunt work for you. There was a talk earlier today about developer efficiency, talking about cooking and staging and deploying and how Epic are making those faster. I think Epic can work with the rest of the community together to produce something that can help make engine upgrading simpler as well. And this kind of is the final answer to how do you take the pain out of engine upgrades. We all work together to make a standardized toolkit that does it for us. So, perforce stream setup. The key thing is avoid blocking your team, and you want to copy your main branch into an engine merge branch. And this is so that you can do that work independently of what's going on. You would have a stream for each new engine version in your perforce. There's a screenshot from Tanglewood's perforce showing all the engine versions. One interesting thing I learned recently is that P4V has a dark mode, which not everyone seems to know. One thing you can do, I would recommend, is make each new engine version a child stream of the previous one, because that way you get at least some sort of history. Although you're only getting just the engine releases rather than all the intermediate changes, at least you can go back through 5.4, 5.3, 5.2 and see how files change when you're trying to fix conflicts. And file moves can't be tracked this way because you're only taking snapshots from Epic. So what happens a lot is plugins will move from experimental to production. So if you have any engine changes in those plugins, you've got to manually move that code over. And even if you don't use engine changes, it's probably worth doing this so you're ready in future, because it's not that much effort to set this up. And then actually, this is one thing that I thought after I'd written this slide. There are kind of two options here. You can either start with your modified version of the engine, if you have code changes, that is. You can either start with your modified version and integrate the new version of the engine over the top, or you can start with the clean version of the engine and integrate your changes over the top. It's probably generally better to do the second option, but it depends on how extensive the changes are. There are balances and decisions to be made either way. And then if you haven't got any engine changes, you just accept source and everything and watch while P4 command line chugs away and does it. And then once you've done the initial integration, you need to build the basics. So you need to make sure you've got all the updated SDKs and Visual Studio and .NET and whatever other third-party dependencies there are. Get them all in place. Generate the project files isn't necessarily essential, but it's a good way of testing that the merge went well and it's actually set up right. If you're not using ushell, you probably should, because it makes the syntax for this kind of thing really easily, and you don't even have to open up Visual Studio or Rider. And this will tell you if anything missing. It means that like UBT and UHT are in place, and the code can at least tell where the plugins are and check the dependencies on things. And there may be some errors here, so but it prints out some quite nice readable errors when you do this, so you can fix them in turn. You probably get it working clean maybe in a day, I think, when I've done this on previous engine upgrades. And plugins can cause issues here. As I said earlier, make sure you're ready with new versions of the plugins. But of course, your own plugins, you'll need to actually change yourself and fix them up. And this also can highlight some dependency issues. Like if module dependencies have changed, you might have to change your build.cs files to pull in the right things again. So once you've got that building clean, you need to try and build the editor. Again, use shell command for that. You will likely see a ton of errors at this point. All your project's code and plugins, well, not all of the code, but a lot of the code will produce errors and you'll need to fix them all up. And this is where the game of whack-a-mole starts and why it takes so long to do an engine upgrade, because you compile, you see a huge list of errors, you start fixing them, and more will come up, and then more, and then more, and you'll keep repeating this process again and again, and it can literally take weeks and weeks or even months. Not just for the editor, but for the whole process end to end. There's a lot of manual work in doing this. Again, remember you should have your new plugins in place. The other thing you need to do once you get it just building is fix the deprecation warnings. And deprecation warnings are put in by Epic. And as a simple example, this is one from UEditor Engine. And it basically says, don't use this function anymore, use this other one instead. So there are some more complex ones, but this is kind of a simple example. It shows that it was deprecating in 5.5, and it tells you what to do to fix it. So that one's quite a simple example. And when you compile, it will print out a warning to tell you, what you did. You should fix all of them. It's more pain if you don't, because on your next engine upgrade, it may go away and you'll just have a compile error and maybe not necessarily know what to do because you don't have this comment. But if you did set up your perforce streams with the history, at least with the child streams for each version of the engine, at least then you can go back and look at the history and maybe find the deprecation warning again if you manage to miss one. And then opening the editor. This is where the whack-a-mole game continues because there will be more errors and crashes to fix. Use map check to help identify asset issues. Once you can open the editor properly, try and pie, and you'll have more and more errors to fix. You're just playing this long game of whack-a-mole. Another thing you should do, I mentioned this in the preparation, but you definitely need to do it for an engine upgrade, is resave all the assets in your entire project. The commandlets here are your friend. As I said earlier, automation is very important. Use the commandlets, not only just the built-in ones in the engine, but ones you've written yourself or your team have written. You can run the command line version of Unreal Editor with this to resave the packages, which works for quite a lot of things. This would have worked perfectly in UE4, but we're in the world of world partition now, so this doesn't work for those. So instead, there's a different commandlet for that. You pass in the map name and run world partition builder commandlet with the world partition resave actors builder. However, this only resaves the assets that are actually directly referenced in that level, at least in 5.5. So what you have to do, you can either use the editor and create a collection and then pass that collection in, which has all the level instances, or what I've done in a previous project is just modify the commandlets. So if you don't pass it a level name, it just runs through the asset database and resaves all of them. And on a big open world game, it took maybe 12 hours, I think, to do the whole lot. It wasn't very long at all. Well, I say not very long, but you could set it off overnight and come back the next morning and it's done. So once the editor loads and you compile, you've got to cook and test all your platforms. And again, you're playing more whack-a-mole here. You're fixing these errors and warnings as you go. Hopefully, you've got a lot of automated tests in Gauntlet, which can keep running. You'll notice there'll be a lot of red to start with, and you're going to turn them all green one by one. And then once that works, that's probably the time to get QA involved and check that the new engine version isn't causing regressions versus the old one. But by this point, your team have continued working in your main branch. So they're possibly a month ahead of, or 2 months ahead of where you are. So you've got to start robomerging from your main branch, and things will break again. You need, as you're robomerging, It's a good idea to automate this so that as each asset is brought over from your main branch, that you resave it with the new engine version as well, so that everything is all ready for 5.6, or whichever engine version you're upgrading to. And then you need to plan when you're going to merge back to main. You can't just have your build engineer go, yep, I've got it all working, let's merge back to main, because your team will hate you. So you have to plan, you have to talk to production, work out when's a good time to do this. Usually maybe the end of a milestone is a good idea because you know that they're working from a known good build. And also they can plan for the next sprint or milestone to deal with any fallout from the merge. And there may be some downtime, especially on larger projects. So one thing you'll need to do is once you've decided when you're going to do it, you're going to have to lock your main branch so no one can change anything in the main branch, and then merge the whole thing back. Which could take a while, but hopefully it's just a matter of hours and not days. But the other cause of downtime will be because no matter what testing you've done, someone will come to work the next day and they'll be like, oh no, I'm not synced. I've got to spend all day syncing in Perforce. So you need to make sure everyone has planned to sync the night, set off their automated syncs in UGS the day before so that they're ready to go the next morning. And also, no matter how much testing you do, you'll have one of your content teams will go, oh no, you've broken my workflow. So they'll either have to learn a new workflow or you're going to have to fix it. So it's likely that after an engine merge, you're going to spend time fixing things again. So, custom engine changes. One of the major strengths of Unreal Engine is you get full source code and you can adapt it however you want. However, you should probably minimize engine code changes wherever you can. And there are a few techniques to avoid this. Firstly, put your code in plugins or new files wherever you can. Use the APIs to interface with the engine code as is, and prefer deriving from engine classes to modifying them. But you can put in small modifications like changing a private to a protected, for example, so that your derived class can use something, or making a function virtual that wasn't virtual before so that you can override it with your own variant. And you need to think about the mergeability of every change you make. So what I mean by this is it can get messy. Like if you have some changes where you have like a small block of change there and another small block and another small block, and it just becomes quite messy. Or another particular example is if you have a function call which has several parameters and you want to add an extra one, you would have just the change for that little bit. But then next time someone else comes along and adds another one. So you've got like two separate changes next to each other. It's better to just put the whole thing in a block for the change and have the original epic one under it. I'll go into a bit more detail about that in a couple of slides. So simple inserts and replacements can be measured with relative ease, but more extensive changes mean more work for every engine upgrade. You want to put something around all your engine changes as well, and do this for every change. Not only because it makes it easier for you to find them, it makes it easier for your automation tools to find them. Because when you've written this script to automate the merge, you want it to find all these things and put them in a change list for you to manually inspect if there are conflicts. A lot of projects use comment for this. So it's a very simple example there, where we put a comment at the beginning and a comment at the end to delimit the change. Unfortunately, I'm not allowed to give anyone the source code for the magical game button. There's a whole initiation ceremony, secret handshakes, passwords, the lot. It's just the whole thing. But we can do better than using comments. Ideally, we want the engine change to be toggleable because we can use that to verify that the merge went correctly. And we can disable things if something goes wrong and you're not sure it's the change that causes it. We want to be able to easily and quickly disable that change. And also, for automation's sake, in Horde, you can have it completely disable all of them to check that the whole engine as a whole still builds like a vanilla engine. And we want to be able to switch changes either all at once or individually. Another thing that can happen is, say you have someone's added something to chaos and your build engineer doesn't really know chaos. Well, while they're doing the merge, they can just turn off that particular change just to unblock them, and then hand it over to the physics specialist who can fix the engine changes in chaos then. And also another thing you can use this for is to test whether changes are still needed. Because sometimes you make an engine change and then Epic will come along and basically write the same thing you did, but maybe slightly differently. And at that point, you can make the decision about whether you use your version or the Epic's version, and you can toggle it on and off and test each way. It's always a good idea to remove your engine changes where possible and keep as close to a vanilla engine as you can. So for toggling engine changes, I mean, as an example, you can put it in build.h, but that's not necessarily the only place you can do it. We put a master switch there, and then each change ends up looking something like this. So it depends on the master switch plus a number, and then you have an if around the new function. So we can toggle both the individual change as well as all of them at once. And you can chain these if your changes are dependent on each other. So if something else depends on this magical make game button, you can make its define, equal that one plus the one at the end. And where to put it, you want to limit the scope and minimize your engine compile times when switching it. So ideally, it just lives in a single CPP file, so only that file is compiled, or just one module's Unity file. If you're using adaptive Unity, which you probably should, when you're making a change, it'll just compile that one file and not everything else. The next option for more substantial systems is stick it in the module's build CS. So you can do things like this, where we add it to private definitions, which means that just that module can see the hash define. You can use public definitions to affect this module and every module that depends on it. So if you make a change in the engine, but you want your game code to still see that Tanglewood custom magical make game, you can do it that way. And then you can still have the things in your game also be toggleable with that switch. And then global definitions means it exists everywhere. You can also put it in header files, but it's harder to explicitly control the scope that way because anything can include that header file, really. So if you want to control the scope, you probably want to do it in the build.cs if possible. So when you're replacing engine code, I would recommend you keep the original code in the else block. This means that when you're looking at this in a merge program, you can see whether the Epic version has changed since your last engine version, which signals to you that maybe you need to change your code as well. Yeah, as I just said. There we go. My slides are, I'm preempting my slides too much. So yeah, and when you upgrade, you just want to copy in the new engine code over the one from the previous version so that you're ready for the next upgrade after that. And you may need to adapt your code as well, depending on what's changed. If you're removing engine code, it's kind of good to keep the same pattern. So put the original code in the else block and just put a comment in the top that says you've removed it and why. Like I put just reasons there, but you want to explain why you've removed it, because if in 6 months' time a different build engineer is doing a merge, they need to understand why that is there. And obviously this will show as a merge conflict if Epic have changed it. Unfortunately, there are some limitations to this. We can't do this. So in a U class, you can't just put ifs around random U properties. Unreal Header Tool does not like it. I mean, Unreal Header Tool can cause a lot of pain, but this is one of them which is a bit annoying for me. Apart from with editor and with editor only data. Instead, we have to use the comments, but at least you can use the, put the hash define in the comments so that your scripts can still find it. And it'll compile, but it's no longer as easily toggleable, but having just an extra T-object pointer probably isn't that much of a problem. I don't know why there's a new line there shouldn't be. Anyway. And next thing to talk about really is moved and renamed code. So Epic will sometimes move renamed files or even entire modules and plugins in the source tree. And as I said earlier, the main source of this is when plugins are promoted from the experimental folder when they're considered ready for production. And if you have custom changes in these files, Perforce can't work this out because you haven't got the intervening history between the two engine versions. But there will be errors, and you can probably, you can see what's happened and usually manually move it yourself quite easily. You only get Perforce being able to figure out what's going on if you're Robomerging every single change from Epic. And that's a whole other talk, as I said earlier. And then, when this happens, you'll just have to manually transport, code engine changes to the new location. So a few extra little tips for engine changes. As you make each engine change, build that file alone. Adaptive Unity will do this if the file is checked out anyway, but Visual Studio and Rider have a shortcut to do this in the build menu, which will just compile that one file. Rider has the extra bonus of being able to do it for individual header files as well as CPP files. I think it works by just creating a dummy CPP file that includes that header. Also, your CI system should be doing a regular non-Unity build anyway, just to ensure that that keeps working. We had, well, I've got Mo in the front row here. We had a project where they didn't do that, and that was fun. Another thing with engine changes is upstream them to Epic if you can. If you think it's going to be useful to other teams, then go through, well, not UD anymore, it's pro support, or go through GitHub to give this change to Epic. And that means you don't have to merge it anymore. It's just there in the engine. Benefits everyone. And audit your engine changes regularly. You want to try and remove changes where you can. So for each engine version you upgrade to, you should check that the changes you have are still valid and still required, and remove them if you can. So what can go wrong with engine merges? There's quite a lot actually, but I'm going to focus on a couple of examples. Things almost certainly will go wrong, especially with large projects, with a lot of code changes. And you may need some creative solutions. So one thing that comes up a lot is serialization errors. Like, oh no, giving an error load in the assets. So you get things like this when you're opening the editor or trying to cook. And it's going, no, the size of that thing is wrong. Usually means you've forgotten to resave some assets with the previous engine version. And you're trying to, that asset was, for example, saved in 5.4. Nobody's touched it in your 5.5 branch. And then when you go into 5.6, 5.6 doesn't know how to load assets from 5.4 or however many engine versions ago it was. So you go back, so you go back to your main branch, you resave the asset there, and then merge it over back to your merge branch and resave it again with the new engine version. That probably fixes most cases, but we have seen it where it can still happen. We had this on a game where, for some reason, instance foliage assets were causing this error, and we didn't quite get to the bottom of why. It may have been caused by a custom engine change, but we're not quite sure. But we kind of used a slightly hacky way of fixing it by changing that error to a warning. Oh yes, let it load anyway, and then resave it, and it worked. I'm not going to recommend that as a general good practice, but it worked in that particular instance. But the point is, sometimes you need to just do something a bit off the wall to try and get you out of an issue. And it's potentially dangerous ground. Another thing that, the last resort with assets that won't load is you're just going to have to delete it and remake it if you can't somehow persuade the engine to load it. So another thing that can go wrong. Oh no, all the level instances have disappeared. We had this in a project, I think it was when we were moving from 5.4 to 5.5. Literally every level instance in the whole level disappeared. It wouldn't show in the editor, it wouldn't show in Pi, it wouldn't show in a cook build. It was just gone. And we were scratching our heads trying to figure out what was going on. And eventually one of the engineers figured out that if we go to build pack level actors in the editor, suddenly all the level instances reappeared again for that particular loaded block. But of course that doesn't work for the entire game, so commandlets are your friend again. There isn't a built-in commandlet for this, but it's not difficult to add one as of 5.5. I don't know if there's one in 5.6, I've not checked yet. But the point is that with commandlets being your friend, you can write your own ones or modify the existing ones to do what you need. And that's nearly it. A little summary. Choice is yours whether to update or not. No one's forcing you to. Don't skip minor versions if you can, because you're going to be in a lot of pain. Get your project before you start the upgrade. Automate as much as you possibly can. Commandlets are most definitely your friend. Fix every single deprecation warning you see. Don't disable them, actually fix them. And you will spend a lot of time playing whack-a-mole with errors and warnings. There will be a build engineer who spends a lot of time on this. And minimize engine changes wherever you can. and make those engine changes toggleable. And then work with your production to work out when the good time is to lock main and merge back. And make sure that everyone, when you do this, sets up an automated sync overnight so that they're ready to go the next morning and don't lose most of their day syncing, especially for remote workers. You can potentially use a whole sprint for this because there may be some fallout. There was a thank you. Hang on. Just a thank you slide there. There's a QR code to my LinkedIn and also to Tanglewood's link tree. Thank you, everyone.